Good morning once again. Okay, so last class from beginning, what we have done is we were just introduced you about what is this Lisp language about, what are the syntax you have to know. That keeping that in mind, how do you declare a variable? How do you define a procedure? And if you are having any conditions to be given, we have seen the syntax with respect to if statement and cut. And if you want to go with in if statement itself, if you want to go with multiple statements, then it's better to go with cont. Because in if statement, if you go with if, then it will be like only one true expression only will be taken. Otherwise, we have to make it to be as a block. So block, we will be studying it little later only. And then if you want any looping, if you want to make use of any looping statement, then we don't have any specific syntax. We have to just make your procedure to be as a recursive procedure itself. That means the same procedure itself will be called again and again. By keeping these syntax, what you have seen is we can define a particular procedure in different ways. Based on the way how you have defined your procedure, we will achieve different types of process. So what are the usual process which we can achieve is either we can achieve linear recursive process, or we can achieve linear iterative process, or it could be tree recursive process. If you are for all these procedures and for this process, if you are based on your input, if the growth is based on your input n itself, then we can call it the order of growth which we can consider will be linear growth itself. So linear growth means theta of n itself. If it is a little bit less with respect to square root or with respect to half of it, then we can represent the complexity, that order of growth, in terms of log n or square root of n. If it is drastically increasing when compared with your input, then we can represent that in terms of exponentiation. So e to the power of something, e to the power of n, or we can say it to be as phi to the power of n, where phi is considered to be as the golden ratio. Okay, so these were the things which we have discussed, and we have seen a few examples how we can define it and what will be the process generated, what is the order of growth. So these were the topics which we have discussed till now. So going forward, next topic what we are going to discuss is about the higher order procedure. So let's see. So in this particular first chapter, whatever we are discussing, it is completely based on procedures. What are the things which you can apply on procedures? How all you can define a procedure? That is what we are going to see in this complete first chapter. Okay, that is the abstraction done on your procedure. So keeping this, so let's start. So in this, say for example, if you are defining a particular procedure called cube, how do you define it? We define saying that define cube x. So everything in the specific thing about this particular language is everything should be kept within the parenthesis. So define cube x. X is nothing but it is having single argument, and as a body of the procedure we are having multiplication of x and closing of all the parentheses. So now when you are defining see, that means we are making some sort of abstraction under the name cube, and we are saying that we whenever you are calling this procedure cube, you need to pass one particular argument. Okay, so since cube is a simple procedure, if you don't do this abstraction, you can even directly use this expression like multiplication of same variable three times. So say multiplication of z, multiplication of say a, or directly the values, multiplication of 5. That also means the same. Okay. But what is the highlight here? Why we have to make it to be as the abstraction? So the importance here is whenever you want, whenever you are describing about any particular language. So all the languages, when you say a language is very powerful or something like that, then that particular language should be in a position to give some sort of maintain some sort of abstraction. even though you can directly do some kind of evaluation onto the expressions, but still if you can put it under a particular name, if you can hide under some sort of the name like cube and all for giving a name and parameters, and if you can hide something, then only that particular language we can call it to be as a powerful language. So that means it is nothing but we can say it to be as the abstraction part. Okay. So just thought of highlighting about what is the importance of making the abstraction. The other thing is whenever you want a particular concept to be repeatedly used, then also mostly we will use this sort of abstraction. And the other thing is the small procedure or the same procedure, say in this cube, we don't have much difference. So sometimes there will be some procedures where we can say that instead of we can define a particular procedure in different ways, as we have seen few examples. Instead of defining the cube procedure by using this multiplication operator 3 times, we could if there is any other way of defining it, we could even define it in that way. That means the point is we don't have to the person who is using it need not know that how it has been defined, how the procedure has been defined. They just have to know like how to use it. So that is the important thing whenever you are coding or whenever you are trying to do some sort of abstraction part. So it should be something like it should be user friendly. Okay, so whenever we are saying the abstraction part, till now whatever we have done is whatever as an argument, whatever we are passing, we are directly passing the values, right? So that means the manipulation by using these procedures, the manipulations, whatever we are doing it onto the arguments, right? Whatever values like cube x. So for x variable, we are just passing the value, and within that procedure, we are just applying those variables values, and wherever those variables were used, we were applying those values and we were executing it, right? So this is how we were just doing it. Now we can even see that you can define a procedure where you can try to manipulate the procedure itself. That means as an argument, we can pass the name of the procedures. So now whatever we are going to study, it is like we are going to make the procedures, that is as an arguments, whenever you are calling a procedure, we can pass the name of the procedures, other procedures also, or the same procedure also. And you are trying to do some sort of manipulations onto the procedures. So these type of things we call it to be as higher order procedure. So that means we can call we can call any procedure to be as higher order procedure if your procedure supports the arguments to be as the procedure, or if it can return a procedure, then we can call the procedure whatever you have defined to be as higher order procedures. Okay. So here along with the values, now we will see how we can pass the procedure as an argument. So first we will see the procedure as an argument. Later we will see how about the return type. For explaining that concept, we have just taken one example, sum of integers. So that means if you are given a particular range of values, it will find the sum of that particular range of values. Can you just give me the output for the first one, some integer 5 to? Just try applying the substitution model and let me know. Whenever you are doing the substitution model, do it step by step. Is anyone trying it out? For the first one, what will be the output? The procedure is defined.
No. Like 5 is greater than 2.
5 is greater than 2. So it will directly return the value to be as 0. Okay. What about the second one?
$18, ma'am.
18. How 18?
I got 16, ma'am.
16. 18, 16.
Okay,
Any
there's a
other
B
numbers?
also.
There is a B. Any other answers?
16, ma'am.
16. How 16?
Ma'am, first 4, 7, ma'am. So if condition will not be satisfied, it will go to the next one, ma'am. So sum of integer a plus a1, that will become 5 and 7, ma'am. Plus a means 5, 7 plus 5. 16.
I
So
got
procedure
22, ma'am.
Yes,
22.
22, ma'am. It's the
22
sum
I
of
am getting.
4 to 7.
4 to 7. Yes.
It is sum of integers between 4 to 7. So it will be like, first, as you said, first you are checking whether 4 is greater than 7. Condition doesn't satisfy. It comes to the else part. In else part, what you will have? You can see, right? In the else part, we have plus a. So what is a current a value? It is 4. So current a is 4. So plus 4. Again, we are calling the same procedure. Sum of integer 4 plus 1, which is 5. Again, once again, we are expanding this. So plus 4 will be there as such. So when we expand this part all alone, it will be like this you will get plus 5, some integer 5 plus 1. So it will become 6. Your B will become 7. Again, we are calling the sum integer procedure. So it will become again plus 6 will come. And after that, you are again calling some integer with 6 plus 1, 7. B will remain same, 7 itself. Again, it checks the condition 7 is greater than 7. Condition doesn't satisfy. Again, it comes to the else part. It will make plus 7 some integer. 7 plus 1, now it becomes 8. So A will be assigned with the value 8. B will be same 7. So now you are checking 8 is greater than 7. Condition satisfies. Once the condition is satisfied, it will return the value 0. So now it will start. Now you can start evaluating this expression. So 0 plus 7, 7. 7 plus 6, 13. 13 plus 5, 18. 18 plus 4, 22. So your answer will be 22. So just a recap. What is the process which you this procedure is generating? The procedure what we have defined. What is the process it generates?
Linear recursive.
Linear recursive process it generates. All the procedures, whatever you are defining, it will be recursive procedure only. Why? Because if your procedure requires any looping concept, then only one way we have is we have to call the same procedure again and again. But the process, what it generates could be different. So, but here for this procedure, what it generates is linear recursive process. So the third one also, you can do it, right? Third one. So A is assigned with the 2, B is assigned with 4. The first time condition doesn't satisfy, it comes to the else part. So it will be +2, then +3, then +4, and then the condition goes wrong. Condition will be satisfied. It will return 0. So you will add 4 plus 0, 4, 3 plus 4, 7, 7 plus 2, 9. So your answer will be 9. Okay. Those who got 16 and 18, is it clear? You can't stop the condition until and unless you get some value. Whenever you are having the same procedure, that same procedure has to be called again and again. Okay.
Yes, ma'am.
So this is one procedure. What we have done is sum of integers. Okay. So same way, asked to find sum of cubes. Sum of cubes, if you are asked to find, here also within a given range of elements A and B. How do you define it? You can define it saying that if A is greater than B, return 0. Otherwise, you are adding the contents by finding the cube of A. So cube of A added with the next content. So how do I get the next content? I'm calling the procedure again. So sum cubes with my next A value. So what is my next A value? How do I get is +1. So A, I am incrementing it by 1 time. So B will remain same. I'm expecting that already I have defined the procedure. Cube I have already defined. So define cube, multiplication of x I have already defined. So keeping that, I'm directly calling it here. Okay. I'm directly applying the cube procedure here. So now tell me if the procedure, if it is sum cubes 3, 4, what will be the output?
91.
91.
91. It will be 3 cube plus 4 cube. Right? What about the second one? Sum cubes? 5, 3?
0.
It will be directly 0. So no need to solve it, right? You can solve it, right? So it will be first you will be calling the value 3 and 4. Then condition doesn't satisfy, it will come to the else part. So plus cube of 3. Then again calling the procedure A plus 1. So which is 3 plus 1, which becomes 4. So again you are calling the procedure. So for condition doesn't satisfy, it comes to the else part again. So plus cube of 4. Then you are calling the sum cube procedure where you are A 4 plus 1, 5. So now once again you are calling the procedure with A to be 5, B to be 4. So 5 greater than 4, condition is satisfied, you will return 0. So then you can then it starts executing. So first you will find cube of 4 plus 0. That value will be added with cube of 3. So now if you see the pattern with the previous one. So previous procedure and this procedure's pattern, if you see, the condition remains same. Return value is also same, but here you are adding it with A value. Here you are adding it with cube of A. Okay, pattern is almost same, right? One more procedure we'll see. If you are given a pattern like 1 by 1 into 3 plus 1 by 5 into 7 plus 1 by 9 into 11. If you are asked to find for this pattern for n values, for a given range of values for this pattern, how we can write it? The condition you can have is like till the condition A is greater than B. If the condition is satisfied, you just return the value 0. Otherwise, what we have to find? We have to find 1 divided by starting value is A, that is 1, whatever number you have given. So that A multiplied by what is my next content? So first, if I say my first value is 1, my next value is 3. After that, there is a gap of, next content, whatever I have, it is starting with 5. The next value is 7. So added with 2. So I can consider it to be as whatever is my starting range, A multiplied by next value, whatever I get is plus 2. So A plus 2. So if you want the result to be in the floating point, you give any one value in the floating point. That is like 1.0. Otherwise, you will be getting the contents in terms of rational numbers. So to avoid that, if you want the floating point value, you mention any one content in the floating point. And by this time, hope you might have come across, like, we don't have any specific data types. Whatever values you want, you can directly assign it. We don't have any specific data types for declaring any particular variables. So plus divided by, if you want the floating point value number, then we can directly say it to be as 1.0 divided by multiplication of A with my next content will be A plus 2. Coming to the next time, whenever I'm calling, I'm once again calling my pi sum. What should be my A? If my A is 1, what should be my next time A? Next time A is 5. So it is increment by 4 times. So if you see, after 5, my next content, whatever is my next content here, which is 9. So 5 plus 4, which is 9. So once I get the starting number, then I can get the next number, 11. So 11 is nothing but 9 plus 2. So pi sum I'm calling, I'm incrementing my first content with respect to 4 times. So this is nothing but it is the expansion. This is for the content pi. So we can define the procedure in this way for calculating for this particular expression. Right? Here also, if you observe the pattern, the condition remains same. Return type is 0. In the else part, if you see, we are incrementing. So plus operator has come, and we are having some content as the first part. So whatever was the expression, whatever we have here, either first time for the first procedure, sum of integers, we had the content to be as A. For the sum of cube procedure, we had cube A. Now we are having 1.0 divided by A multiplied by A plus 2. So this is our first content. Similarly, after that, we are again calling the same procedure. Either first procedure, if you have seen, it was A was incremented by 1 time. Second procedure, sum of cubes also, if you see, we have incremented it by 1 time. Here, if you see, we have incremented it by 4 times. But we have almost all the procedures are having the same pattern, right? So the point is, if you can just bring all the procedures whichever are having the same pattern, whatever I have told right now here. So we had first discussed about the sum of integers. Second example, what we have discussed was sum of cubes. The third procedure, whatever we have discussed, was pi sum procedure, where if you see, the condition remains same. For all the three, condition remains same. If that condition is satisfied, it returned, for all the three procedures, it returned the same value 0. If the condition is not satisfied, what it was doing? It was adding. For all the three procedures, add operator only we have used. And we were adding it either onto the same variable A, or we are cubing that same variable A and applying it, or we are applying 1.0 divided by A multiplied by A plus 2. That means some expression we have given. As the second part, what we have, we are calling the same procedure by incrementing A by 1 time in this procedure. B remained same. In the second part, second example, if you see, we are calling the same procedure sum cubes, incrementing the A by 1 time, and B remained same. The third procedure, if you see, pi sum, we are incrementing A by 4 times and B remained same, right? So now, instead of defining for these three procedures are defined for three different purposes, right? Instead of defining these three procedures in a different ways, what we could have done is we could have defined a common procedure. So how we can name it? I just defined a procedure, give some name to this procedure. Any name can be given. How many arguments you are expecting? Starting range and the ending range. How about the condition? For all the three procedures, the condition remains same. So that condition, whatever it is, which we have returned as such. Return type is also same, so 0. Coming to the else part. So in the else part, for all the three procedures, it was plus itself. So plus came as such. For all the three procedures, plus remained same. So plus came as such. Coming to the second part, that is the after plus what content we have. In the first one, we were applying it as such. The second one, we are calling some procedure and we are applying it. The third one, we have some expression. So what does that mean? We can have some procedure we can call on to this value A, right? So keeping that, what we have written is we can name this, right? So we can say that some procedure name if we pass and apply it onto the A value, we can use it. So what I have done is I have just whatever name I want to pass here, that I have taken it in terms of term. Okay, so some procedure if I apply here onto this variable A, I will get either that same value A, or I can apply cube on this, or I can apply this procedure. Okay, after that what I am doing, I am calling the same procedure, some integer. When I have defined some integer, I am calling some integer itself. Some cube, when I called some cube itself, I have defined, I'm calling it again. Pi sum means pi sum itself, I'm calling it again. So I need a loop here. So since I need a loop here, what I'm doing, the same procedure name, whatever I have given, that same name I'm calling it with what? What should be my next A value? My next A value here, it was incremented by 1. Here also it was incremented by 1. But in the third procedure, we have incremented it for 4 times. That means the value, how many times the A has to be incremented, kept on changing. So for that purpose, what we have done is, we have given another name called next, procedure next. Just to find out when I apply this next procedure, how it will and it takes the same A value, it will return what should be the next value. Either it should be incremented by 1 or it should be incremented by 4 times. So I just gave a name of the procedure here. So now what it means is I am defining a new procedure with some name where I have the starting range of the value, I have the ending range of the value. Along with these two contents, I require two more informations, like what is the difference here. I have to apply one procedure. So some that procedure what I am going to apply, I made it to be as term. The other one which I'm going to apply, that is for this A should be incremented by how many times. So that also I can that I have defined, that I'm going to take it in terms of next. So along with these two arguments, I need what procedure I'm going to apply it onto the A. Along with that, I need what should be my next A value. So these two are my procedures. So I have redefined it in this way. So I have given the name of the procedure to be as sum. Instead of 2 arguments, I will be having 4 arguments. A and B, which will give me the range of values. Term, which will tell us like what should be the procedure applied onto the A value. Next procedure, which will tell us about what A should be incremented by how many times. So if you see the pattern, it remains same. I have only four arguments here. If condition A is greater than B, return 0. Otherwise, I am applying this plus because this procedure has been defined for the plus operator. So plus summation of series. So plus whatever is the procedure I have to apply, that I am applying it with respect to the term of A. And again, I'm calling the sum procedure. Term remains same because I don't have to change anything. So whatever procedure name I'm passing, that will remain same. What about my A value? A value should be incremented or decremented based on the content. So accordingly, I will define the procedure next. So since it has to be called, I have written it within the brackets and I'm passing A. And when I'm calling the next will not change. So that name next, whatever we have passed, that will remain as such. Similarly, B, which is my ending range, so that also will remain same. We are not going to change. So let's see with respect to the first example. So I have just defined this, which we can keep it to be as the common procedure for all the three. So now if I have to find sum of integer values or sum of cube, some cube procedure, if I have to find, what I can do is I'm just defining another procedure INC, which is for incrementing it by one time. So I'm passing an n variable and just increments it by 1. Okay. My main procedure sum cube. Define sum cube. I'm asking the user the starting range and the ending range. Inside this, I don't have to define it again. I can directly call this sum procedure. So sum procedure. What should be my term here? Term is nothing but what is the content what I'm going to apply here onto my A value. So what I'm going to apply, which is cube procedure. So I'm just passing the name of the procedure. All of you be clear. Here I'm just passing the name of the procedure here. A is the value. So it's a variable. Next procedure, which is nothing but what should be my next A value. So for that, what I am applying is I'm just passing this INC procedure, which is increment procedure. Just the name of the procedure I am passing. What about my B? B is nothing but the ending range. So B value, whatever the user passes, that will be given here. So control comes here. Control will be here. So control reaches here whenever we call, it executes. It executes and it returns the value. Shall we do it for one example? For small example, if we are going to find out for sum cube, I'll just write it to be as SC. So sum cube, your starting A value is 2 and ending B value is say 3. What happens? We first call the sum procedure. I'm just writing S, where we are passing cube as the one argument, name of the procedure, cube. The starting range starts with A, so 2. INC is my other procedure which was already defined. So INC B, which is 3. So the sum procedure is getting called with these 4 parameters. Hello? Hello?
Yes, ma'am.
I think in between we were lost, right?
Yes, ma'am. Last 1 minute.
I'll just put it here so that I can type. Procedure where we had the starting range 2 and 3. So from here, we are calling some procedure with cube as the argument which we have passed, A which is 2, and INC is the procedure which we are passing, 3 is the procedure. So once it reaches here, it will check whether 2 is greater than 3, condition doesn't satisfy. So it will come to the else part. In the else part, it does plus operator. And since the cube procedure has to be applied, if you see here, it is within the parenthesis. So whenever there is within the parenthesis, then only the procedure will be called. So cube of the value of A is nothing but 2. Next, we are having again the sum procedure getting called. Some procedure getting called with cube remains same. What about my A value? A value should be incremented. So what happens? In place of next, it will be INC procedure. What is my current A value, which is 2. Next, the same INC will remain same, 3 will remain same. So this will be the second procedure call. So now, whenever we are calling this sum procedure, cube this one. So here what happens? This procedure value will be applied. So INC of 2 means it comes here. It will apply 2 plus 1. So it will return the value to be as 3. So I have directly written the value to be as 3 here. So this plus cube of value 2 will come as such. Some procedure is getting executed. So condition 3 is greater than 3. Condition doesn't satisfy. So it will come to the else part. So in else part we have plus on 2. Again term remains same thing, cube. Now what is my A value, which is 3. So it applies cube of 3. Next time again I am calling the sum procedure where the term remains same, which is cube. What about my increment procedure? Next, INC. Now what my A is 3. So INC of A. Now my current INC will remain same. B will be 3. Plus operator is closed. My second plus is closed. So now once again INC procedure is getting called. So where my N value is 3. So 3 plus 1, 4. So here in place of this procedure call, it will return 4. Now, once again, some procedure is getting called with all these numbers. Rest all will remain same. So cube 2 plus cube 3. Now, 4 is greater than 3. Condition is satisfied. So it will return the value to be as 0. So once it gets once you receive the value 0, now what happens? It will start executing. So cube of 2. Now plus. So first the procedure cube should be called. So cube means 3 into 3 into 3. So which will be 9 into 3, 27. So 27 plus 0. So plus cube of 2. So 0 plus 27, it will remain same 27. Now plus cube of 2. So it will be 2 to 4, 4 to 8. So 8 plus 27. So it will be 35. So this is how the execution, the substitution model is being applied, and this is how it will be executed. So the highlight here is when we are calling the procedure, if you have seen here the procedure along with the value as the arguments, we can even pass the name of the procedures also. So that is the highlight over here. Is it clear? But you should be careful where you have to get the procedure being applied. There you have to write the contents by using these parentheses. Then only the procedure call will happen. Otherwise, the procedure call will not happen. Same here also. Here we wanted the procedure call to be applied, whatever be the name of the procedure. So we have written it within the parenthesis. Okay. Okay, till here is it fine? So that means we here when if you have defined a common procedure called sum, we can use this sum procedure for any type of summation of series for any summation of series procedures. We can use this sum procedure. We just have to define the supporting procedures, like it should be incremented by how many times. So I just have written the procedure called INC where it should be incremented by plus 1. So that procedure I have defined, and already a cube small procedure which was already defined. So these small procedures, if we have, we can directly call the sum procedure by just calling these three by passing these as the arguments. Okay, so that same thing but with respect to PySum procedure, if you try PySum procedure, where I'm just asking the user, PySum procedure where I'm asking the user what is my A value and B value, and here I want the term to be applied. So what should be my term here? It should be 1.0 divided by multiplication of A with A incremented by 2 times. So that thing I have defined it under a name given PyTerm. So PyTerm procedure, I have defined it by taking some X as the argument, where I have applied 1.0 divided by, that is division of 1.0, brackets open, multiplication of X with my next X term will be incremented by 2 times. So plus X2. So closing off all the parentheses with respect to PyTerm. Next, I have defined PyNext procedure. Say asking what should be the next, first my whatever is my A value, it should be next time when I'm calling the A value, it should be incremented by 4 times. So I have just defined the PyNext procedure where it accepts the argument X, and it should what should be my next X value incremented by. So X plus 4 has been mentioned. So I have closed PyNext procedure. So if you have seen here, I have defined PyTerm procedure and PyNext procedure inside PySum procedure. As the body of the PySum, I am just calling sum procedure where my term will be nothing but PyTerm. I'm just passing the name of the procedure, PyTerm. A is whatever the user has passed the A value, this A, that same A I am passing it. As the next procedure, I'm just passing my PyNext procedure name of the procedure only I'm passing it. B, which is value, what the user has already passed. And then I'm closing this. This define is getting closed here. Okay, so that means I have made use of the block structure. So that means I can use this PyTerm procedure and PyNext procedure only from PySum. From outside this, I cannot use it. This PyTerm and PyNext is specifically for PySum procedure. Okay. So now, whatever based on the value of A and B, it will be called, and PyTerm, instead of that particular expression, you are just directly calling it. So the control reaches here and it will be executed. Okay. So today's new thing which you have studied is you can define a procedure and you can pass that name of the procedure as an argument. But where it has to be applied, there you have to write within the parenthesis. So here you wanted the procedure call to be happened. So here you have written it to be as the same procedure. I mean procedure call to be happened. Similarly here you don't want the procedure call to happen, so you are directly writing the name of the procedure, a name as such. Here you wanted the procedure call to happen, so you have put within the brackets, parenthesis. I'll stop with this. We'll continue in the next class with lambda. Okay. Any doubts with respect to this topic till now? Okay, then we shall wind up then.